it's very modular. It's very easy to maintain code because you're using a lot of code in these modules and packages that you don't have to think about. They work. They're black boxes as far as you're concerned. Um, so that's good. Um, and this last point just kind of repeats what I said before. Let me get this out of the way here. Okay, so a couple more advantages. First of all, and I guess it's not even listed. Yes, it is. It's extremely popular. And depending on who you ask, if you Google the most popular data science programming languages, Python will be near the top of the list every time. Now, again, it depends on who you ask, but it's used quite a bit. And as a result of that, also, there's a lot of free resources on the internet. It's a very nice thing. You get stuck on something and you can just call up Dr. Google and ask Dr. Google for a solution to your problem in Python, and you'll often find it. Okay, so there are GUI, you can develop GUI apps, you can develop full-blown web applications. We're just going to be looking at little apps that we run in the console, that we run in the interactive shell. Okay, and it's open source, and I guess I don't have to preach the advantages of open source. Paying is always an encumbrance and a detriment as far as I'm concerned. Okay, so this goes to the steps that are used to actually run a Python program. Now, you can use anything for a code editor. You can use WordPad. Code, the initial source code, which is the .py file that you create and that you ultimately will have interpreted, compiled, and run, is just text. And text is just basic ASCII characters. There's no special symbols or proprietary type symbols like you would find if you tried to open up an Excel file inside of WordPad. You can create Python programs using a WordPad or Notepad. But of course, most people will use some sort of integrated development environment, or IDE, of which IDLE is one IDE. There are others, of course. Collab, COLLAB, is a really cool cloud-based Python interpreter. If you Google, it's a Google product, as you might imagine. Probably can find it under Google, collab.google.com, which will run your own Python programs, and you, of course, can share them with people. It's pretty cool. Anaconda is another IDE that we won't be using. What are some of the other? Jupyter Notebooks. There's various flavors of these IDEs that are popular with Python. Okay, so at its basic level, you use some sort of code editor just simply to create a text.py file, which is your source code. And using Python, the Python software, it will interpret all of that source code and it will convert it into bytecode. And bytecode is kind of a machine type language. But to run it on an individual machine, the machine must have the Python virtual machine installed, which interacts with your operating system and permits the bytecode to successfully execute on whatever type of system you're using, Windows or Mac or Unix. So the virtual machine translates the bytecode so it can be run on a wide variety of different operating systems. Okay, so that's the basic process. Now this next slide elaborates on that a little bit. Right, and this basically just kind of repeats what we just went over, but the procedure is somewhat complicated, but it runs behind the scenes when you're developing Python programs. So it's mostly invisible to you. The Python bytecode can be run on any operating system that has a Python virtual machine installed. So this is why Python is usually described as platform independent. It'll run on any platform as long as it has the Python virtual machine installed. So now most of the programs, including programs that we'll be developing here, will import one or two additional modules. There are a number of modules that come with the Python base installation. And think of these as additional programs, extensions that enable your own program to do specialized things like formatting currency without you having to write the code yourself. Okay, so the modules that you will import and run as part of your little programs contain reusable code. Okay, so the compiled bytecode, in case you wanted to know, is stored in files that have a .pyc or .pyo extension. So,
Jeffrey, can I interrupt and ask a really
of course, anytime.
simple question? And if it's not like super important or material to what we need to know, then that's fine. I just want to make sure I'm tracking.
Let me just say this one thing. This is your course, and anybody can jump in with a question anytime they want. Okay, so that's my short answer to that. Okay, so what's your question?
Yeah, my question is this. I understand the relationship between, how we, develop source code on pretty much any program we want, right? Whether it be something as simple as WordPad. And I also, I get then I get the code editor to the source code to the interpreter. I guess I'm confused as to what the relationship or why bytes then are necessary in this whole process.
That's a good question, and I don't think I have the entire answer. But bytecode is more of a machine language type perspective. If you saw the bytecode, it probably would look like gobbledygook.
Okay.
So that's what that is.
Got it. That helps. Thank you.
Sure. Okay, so let's jump in here and use idle. Now, I think I already have it running. Yeah, I do. Okay, so here's the idle shell. If you've installed it, you ought to be able to find it just in your search. If you're using Windows, you can just type idle in search, and it ought to be able to find the idle shell. Now, mine probably looks a little different than yours because you can edit the look and feel, which I have done here in options. You can go into options and configure ideally. And I usually make the font at least 16 points and bold because I'm getting on in age and it helps me see it. But you can do a lot of other things as well here in the options. So it looks something like this. And again, idle is an integrated development environment. It's a reference, the name idle came from, it's a reference to one of the founding members of the Monty Python comedy troupe. Okay, so let's go over here. Let's do a couple of these. So if you start up idle, the prompts enable you to just enter a line of code and then hit enter, and it will be interpreted and then compiled and run. And of course, computers are great calculators. So let's just do a couple of these real fast, right? So, print command that returns whatever the argument is back to the screen. So let's use the old computer science example of hello world, print hello world. And you've got to put it in quote marks because it's a string. And you'll notice when I completed that, let me show you that again, right? So I say exclamation point, double quote, and then I close the paren. It briefly highlights that, the argument. And what that is, it's a note to you that it looks okay. There's no syntax errors, right? And so you hit enter and it just simply returns the string, hello world. Python ignores spaces mostly, with some exceptions, right? So you say 8 plus 5 and it returns the result. It adds the two integers together. Say 10 divided by 3. And again, I'm ignoring the spacing because it would take me longer to type. You get a float, right? So integers, as you may probably know, integers are whole numbers, right? 0, 1, 2, 3, 4, it's whole numbers. Floats, on the other hand, is just a term for a real number, a fractional number. And in this case, the float is actually continuous into infinity, I believe. Notice that Python messes it up. And this is a problem with floats, real numbers. It is imprecise often to a very infinitesimally small amount in showing the result. So you got to be careful with floats, especially if you're really into precision and you want everything to be perfect. But it's not a huge problem. Okay, so 8 plus 2 times 3. And you can tell that it added the two integers together and then it multiplied it by 2. If we type something in that is syntactically incorrect, like this, we say prints and we mean this to be a string and it's not really a string. Out there, we'll get a syntax error, we'll get an exception. And it tries to be helpful and generally will tell you where the problem is. In this case, I didn't forget a comma. I didn't put the quote marks in there. Okay, so just to wrap this up real fast, right? So we say, let's vary this a little bit. We'll say x equals 5, and then a built-in Python function to tell you what x is. You can just say type of x. It's of the class integer. And we'll say y equals 3.33333. And we'll say, what's the type of y? And it's a float. And then we'll say z equals David. And we say, what's the type of z? It's a string. We're going to get more into things that you can do and the characteristics of ints, floats, and strings more in day 2, but they need to be introduced early. No, we can do things like this. We can say x plus y, and what we're doing here is we're trying to add an integer with a float, and that works just fine because it turns the result is a float. It turns x into a float. It can add an integer to a float without losing any information. But of course, if you do something like x plus z, you can't add an integer to a string. And so you'll get this type error. This is an exception, of course. You're trying to use an addition operand with a string, and it doesn't like that. Okay, so, and again, here's another thing. If I say capital X plus 15, again, that also draws an exception. Python is case dependent. A smaller x, a lowercase x, is not the same variable name as an uppercase x. So you can't use them interchangeably.